Hi, this is a presentation and demonstration of VaRGB, a free software RGB illumination control library that allows you to easily control settings, transitions, and behavior of RGB values with time. VaRGB is designed for use on microcontrollers, but it's written in standard C++ and doesn't include anything platform specific, meaning it should run on anything, including desktops, Raspberry Pi, AVRs, Arduino, or any target you can compile C++ for. VaRGB is hardware agnostic in the sense that it doesn't know or care about the details of the particular RGB lighting you're using. A callback informs your code when and how to update the red, green, and blue values, and you handle communication with the hardware however appropriate. In this way, VaRGB can be used with anything from LED strips and megabrites to standard LEDs controlled with pulse width modulation. You set up VaRGB by creating schedules of transition curves. As it runs, the library will use the callback to inform you when it's time to change the settings for red, green, and/or blue. When you set up VaRGB, you create one or more schedules. These are ordered lists of transition curves, each of which has a specific behavior and duration. While in operation, you'll mainly interact with the VaRGB driver by informing it of the passage of time, and do your thing in the callbacks to update the actual displayed values or swap out one schedule for another. The power of VaRGB lies in how you use and combine the various transition curves. There are a number of built-in types. Some of these are atomic or fundamental, curves that have specific predefined behavior like linear, constant, or sine curves. Logical curves allow you to affect one or more other curves. With these, you can apply transformations that provide for unlimited variation and control. These curves include AND, an intersection of two curves, or a union of two curves, NOT, an inversion of one or more channels, threshold, and shift. Using logical curves, you can stack transitions to any depth your processor's RAM can handle and do some pretty neat stuff. I'm going to run a couple of the example programs that come with the library. These programs were compiled for and run on a SolarBotics Arduino, a cool little Arduino compatible that only takes as much space as a single chip in your circuits and cheap enough to leave embedded everywhere. For the lighting, a single Megabrite was used with the TinyBrite library. You can see a few Megabrites in the background here. Because the Megabrites take a lot of juice and a higher voltage, I set up the Arduino on a protoboard, powered the Megabrite with a 9-volt supply, and put in a 7805 voltage regulator to feed a nice and safe 5V to the Arduino. The second demonstration includes the output to the serial monitor, so in that case I powered the Arduino from the USB port and kept the Megabrite supply separate. This is the phase sine example, which is a sine curve for each of red, green, and blue, where the green sine is phase shifted 90 degrees and the blue 180. It's a little overpowering for the camera to capture, so here's the same code as seen from behind the LED. I love the effect with the shadows due to the different positions for the red, green, and blue. Now we come to the logical song sample code. Here I put the Megabrite behind a sheet so we can see the values for each channel through the serial monitor at the same time. The first curve is a simple flasher, alternating between all off and all on. Next is the same flasher with a logical NOT applied to the green channel, so it's inverted. Here's a single sine curve going from black to max value for each RGB channel. Now a sort of throbber, a half-rectified sine wave created by applying a minimum threshold to the sine curve. Like the inverted flasher, this sine wave has a NOT applied to the green channel, leading to this alternating effect. This is a half-rectified sine wave on green, like before, but with full rectification on the red and blue channels, using some AND masking and OR unions. And here's the grand finale. A simple sine wave on blue, a sawtooth created by bit masking and left shifting a linear curve on green, and something hard to describe but rather pretty on red, using the same trick as for green, but on a sine curve. I hope you enjoyed this presentation and that VaRGB can be of assistance in some cool projects of your own. If you do use VaRGB, I'd really like to hear about it, as well as any problems or questions you may have. Just get in touch through the contact on the website. Thanks, have fun.